Now let us discuss symmetrical networks. What we mean by symmetrical network is something like this. Imagine that you have been given a situation in which several resistors have been connected in this particular fashion. Assume that all the resistors are same R, and here you have to find the equivalent resistance between point A and point B. This kind of network we are calling that they are symmetrical network, because if you draw a vertical line from this place, then the left side and right side of this network, they maintain similar kind of situation. यहाँ लेफ्ट में जिस तरह के रेजिस्टेंस की पोजीशन है, राइट में भी रेजिस्टेंस की उसी तरह की पोजीशन है. फॉर एग्जाम्पल हियर यू हैव आर, सो हियर यू हैव आर. इफ दिस इज आर, दिस इज आर, दिस आर एंड दिस आर, दे आर काउंटर पार्ट, and this entire resistance R can be divided into two parts. Now if this kind of situation is there, then try to see, in case you inject some current from this side, then what kind of current flow will be taking place in this entire network. Remember that whatever current will be flowing in this resistor, in the counterpart resistor there, you will have to flow the same current. What I mean to say, in case current X is flowing here, then current X must flow here. You understand? जिस तरह की करंट इधर की रेजिस्टेंस में फ्लो करेगी, उसके काउंटर पार्ट उधर के रेजिस्टर में भी उतना ही करंट फ्लो करेगा. Now, if let us suppose current Y is flowing here, then you can clearly see that current Y will be flowing here. If current Z is flowing here, then current Z will flow here. And let us suppose the current W is flowing here, the same current W must have flown here. You understand? ये जो नेटवर्क हमने पूरा दिखाया, this is a symmetrical network. What was the problem involved with this network? In this network, anywhere you could not apply series parallel combination, anywhere you could not apply Wheatstone bridge. That is why we have adopted another approach, because this network was symmetrical. Since ये symmetrical network है, इसलिए आप इसमें corresponding branches में same current flow करा के analyze करें that what is happening. You carefully see this particular junction. अगर आप इस junction पे concentrate करेंगे, then you can see, अगर नीचे से current X आया तो the same current X has flown here, and in case a current Z has come from top, then same current Z is moving here. You see that? इस पर्टिकुलर जंक्शन पे करंट की कोई मिक्सिंग नहीं हो रही है. देयर इज नो मिक्सिंग ऑफ दिस करंट एक्स और जेड एट दिस जंक्शन. दैट मीन्स दिस जंक्शन इज नॉट प्लेइंग एनी रोल एट ऑल. अगर आप इस जंक्शन को ब्रेक भी कर दे तो भी करंट की फ्लो अफेक्टेड नहीं होगी. दिस इज द पंच लाइन टू सॉल्व दिस क्वेश्चन. यू अंडरस्टैंड? लेट्स सपोज आई शो द डायग्राम अगेन बाय ब्रेकिंग दिस जंक्शन. Then it will look something like this. You see, I am breaking the junction like this. You understand? This was the idea behind solving this question. आपने इस जंक्शन को ब्रेक कर दिया तो भी in case current Z is coming from top, Z will be going here. In case current X was coming here, the same current X will be coming here. the flow of current was not affected. What does it mean? इसका मतलब ये हुआ कि equivalent resistance of this combination and equivalent resistance of this combination will be same, because current flow network in both the combinations, that is same. But in case you have broken this junction like this, आपके जंक्शन के इस तरह ब्रेक करने से this circuit has been simplified. ये सर्किट बिल्कुल सिंप्लीफाई हो गया है. Why? Because now you can see that these two resistors can be understood to be in series, and उसके साथ फिर this resistor will be in parallel, then all three will be in series, lower two will be in series, and together they will be in parallel. If I redraw this circuit, it will appear like this. You see that? Now here you start your series combination. Here this is R and R, this is 2R, and together with this R they are in parallel. So you can say the lower portion, this 2R, is present here. On the upper side, this 2R along with R, that will be 2R by 3. This entire network now looks like this. ये 2R by 3 कैसे आया? This is 2R and R in parallel. So 2R into R upon 2R plus R. So that is 2R by 3. And now this 2R by 3 is in series with this total 2R. You see this? This 2R by 3 is in series with this 2R. So that value will be, in case you redraw this, then this side you will have 8R by 3. How did you get this? This is 2R by 3 plus R plus R. You understand? 2 by 3 plus 2. So that makes it 8R by 3, and the lower side is 2R. And now further 8 by 3 and 2, they will be in parallel. So that will make it finally 8R upon 7. This will be your, how did you get this? This is again the parallel combination of these two resistors, 8 by 3 into 2 upon 8 by 3 plus 2. So that will make it 8R by 7, and that will be the final answer. So now you saw that in case series parallel direct application is not appearing, Wheatstone bridge is not appearing, but in case you can locate some sort of symmetry in the question, then you can apply this kind of idea and this entire question can be solved. But now let us suppose even these three things are not there. Then the master formula is coming from a rule which you call Kirchhoff's rule. So let us now discuss Kirchhoff's law or Kirchhoff's rule. Now let us discuss Kirchhoff's rule. This rule or law is used to solve complicated networks. What is the use of this? Used to solve complicated networks. Most of the questions in which you cannot apply the concept of series parallel combination or you cannot apply Wheatstone bridge combination, then Kirchhoff's rule will be helping you. There are two rules or two laws related to Kirchhoff's law. Let us first discuss the first law. Kirchhoff's first law is also called junction law. This is also called junction law or the law of current or the law of current. Remember that this is based on conservation of charge. This is based on conservation of charge. This is a very important point regularly asked in your question, that the Kirchhoff's first law is based on which conservation law. So remember that Kirchhoff's first rule or Kirchhoff's first law, this is based on conservation of charge. Now what is the statement of this law? To understand this first law, imagine the situation that on a particular junction several currents are approaching or receding. Let us suppose you have a junction in which current I1 is coming from this side, current I2 is going this way, current I3 is going away, current I4 is coming in, current I5 also let us suppose coming in. Now see, the conservation of charge says that on a particular junction there will not be any production or vanishing of the charge. एक जंक्शन पे ना तो चार्ज प्रोड्यूस हो सकते हैं ना वहां से गायब हो सकते हैं. दैट मीन्स जितने अमाउंट ऑफ चार्ज यहां पे आएंगे सेम अमाउंट ऑफ चार्ज यहां से चले जाएंगे. नथिंग विल बी गेटिंग स्टोर्ड ऑन दी जंक्शन. इसी फैक्ट पे ये बात होगी दैट वॉट एवर नेट अमाउंट ऑफ करंट इज कमिंग इन, सेम अमाउंट ऑफ करंट विल बी गोइंग अवे. यू अंडरस्टैंड? सो द स्टेटमेंट विल बी दैट द नेट sum of current on a junction is zero. This is the statement. If you apply this statement in this particular junction, अगर आप इस स्टेटमेंट को इस जंक्शन पे अप्लाई करेंगे, then take one direction to be positive and another direction to be negative. If that is so, let us suppose incoming को आपने positive कहा, then outgoing will be negative. Then I1 is coming in, so this is I1. I2 is going away, minus I2. I3 is going away, minus I3. I4 is coming in, plus I4. I5 is coming in, plus I5. And this will become equal to 0. This will be the statement, numerical statement of the first law. You understand? So what are the important points you have to remember about the first law? Is that it is based on conservation of charge and the net sum of current on a particular junction is 0. Now let us discuss the second law. Now let us discuss the Kirchhoff's second rule. Kirchhoff's second law. Remember that to understand this law, there are certain prerequisites. There are certain basic concepts we expect from you. First thing, let us suppose a current is flowing in a resistor R current I is flowing in a resistor R, then remember that this end is at higher potential and this end is at lower potential. By convention, remember that in the direction of current flow, in case you are moving, then you are moving from higher potential to lower potential. This H stands for high potential and L stands for low potential. So if you are moving from left to right, then remember that your potential will be decreasing by IR, so you will be losing a potential IR. This is the first thing you have to remember. If you are moving in the direction of current, then you will be losing potential by IR. In case you are coming from that side, that means you are moving from lower to higher potential, you will be gaining potential. Sometimes L is shown by minus sign and higher side potential is shown by positive sign. That is simply a convention. But do not be under this impression that this plus is showing a positive charge. No, that is not the meaning. You understand? यहाँ पे plus और minus higher and lower potential को indicate करते हैं and not that they are representing charge. This was the convention for resistor. Now let us suppose while solving a circuit, you come across a voltage source. If you come across a voltage source, then always the convention is that this is at higher potential and this is at lower potential. So while solving a circuit, in case you jump from plus to minus side, then you will be losing potential by V. In case you are coming from minus to plus side, you will be gaining potential V. You understand? The direction of current is immaterial here. यहाँ पे current की direction matter नहीं करती. हमेशा जो larger line है that will be at higher potential, जो smaller line है that is at lower potential. अगर सर्किट सॉल्व करने में आप इधर से इधर जंप करेंगे तो आपका पोटेंशियल लूज होगा बाय V, और इधर से इधर आएंगे तो आपका पोटेंशियल गेन होगा बाय प्लस V. नाउ रिमेंबर दैट किरचॉफ्स सेकेंड लॉ is based on conservation of energy. This is another important question you have to remember. अक्सर ये पूछेंगे कि किरचॉफ्स फर्स्ट लॉ एंड किरचॉफ्स सेकेंड लॉ कौन कौन सी कंजर्वेशन लॉज पे बेस्ड हैं. Then you had seen Kirchhoff's first law was based on conservation of charge, but the second law is based on conservation of energy. Now, what is the statement of the second law? Second law says that total potential drop around a loop. Total potential drop around a loop is zero. You understand? This is the statement of the second law, that total potential drop around a loop is zero. Now you see, so long as question solving is concerned, it will be very rare that we will be asking you questions on the total potential drop around a loop. क्वेश्चन सॉल्व करने में पूरे लूप में मूव करने की जरूरत नहीं भी पड़ सकती है. इट मे बी अ सिचुएशन इन विच इन अ नेटवर्क फ्रॉम वन पॉइंट टू अनदर पॉइंट यू हैव टू फाइंड आउट द पोटेंशियल डिफरेंस. मतलब ज्यादा से ज्यादा क्वेश्चन में हम ये पूछ सकते हैं कि इस इंटायर नेटवर्क में किसी दो पॉइंट के बीच में पोटेंशियल डिफरेंस क्या है. सो आई विल सजेस्ट यू शुड कॉन्सेंट्रेट ऑन दोज क्वेश्चंस मोर इन विच the potential drop between 2 points is to be calculated rather than solving some complicated network questions on Kirchhoff's law. That is not really asked. So let me highlight this Kirchhoff's law, first law and second law, with the help of an example. Let us take an example on Kirchhoff's rules. Imagine a situation in which you have a network like this. This is resistance 2 ohm, this is resistance 3 ohm, this is resistance 3 ohm, and this is resistance 2 ohm. Current 2 ampere is flowing here, which is essentially coming out from this end with the same value, and say here is a point A and here is another point B. You have to find VAB. If nothing is mentioned, then you should understand VAB stands for VA minus VB. VAB का मतलब VA minus VB लेके चलेंगे हम. You have to calculate in this question that A और B point के बीच में potential difference क्या है. This is the kind of question you should concentrate more. Now you see, if you see this current, then it is having two paths to move from left to right. If you see the upper part, ये 2 ohm plus 3 ohm 5 ohm हो गया, नीचे 3 ohm plus 2 ohm 5 ohm हो गया. Then this current has equal possibility in passing through both the branches. That means this 2 ampere will be equally divided into this part and this part. So if you divide this 2 ampere, what will you get? You will get 1 ampere current flowing here and 1 ampere current flowing here. You understand? This is essentially Kirchhoff's first law you have utilized here. Because on this particular junction, if 2 ampere current was approaching, then that was getting divided into two parts, and the total amount 2 ampere is receding from this place. You see this? अगर आप इस जंक्शन पे देखो तो हमने Kirchhoff's first rule essentially लगाया that if 2 ampere current is coming in, then 2 ampere in total is going away. You understand? And then this 1 ampere will be coming from this side, moving away. This 1 ampere coming from this side and joining, and finally 2 ampere will be moving to that side. Now your next work will be to assign positive and negative sign to any of the resistors which is involved in calculating the potential difference between A and B. If you have to find the potential difference between A and B, what you will have to do, you will have to move through a network. आपको A से B तक ये सारे नेटवर्क के थ्रू चल के आना पड़ेगा, because of which बीच बीच में ये रेजिस्टर्स मिलेंगे. So you should clearly know what is the current flowing in that resistor and कौन सा पॉइंट हायर पोटेंशियल पे है और कौन सा पॉइंट लोअर पोटेंशियल पे है, that also you have to indicate. Now if you remember just now in the convention we had said that in case a current is flowing this way, अगर एक रेजिस्टर में करंट ऐसे फ्लो करता है, then that current flows from higher to lower potential. करंट हाई से लो पोटेंशियल में फ्लो करता है. That means a plus sign will be awarded here and a negative sign here. यहां पे एक प्लस और माइनस साइन इस तरीके से लिखा जाएगा. On the similar line, if you see the lower resistance, then current flows from higher to lower potential. तो यहां भी higher potential plus sign यहां लिखेंगे and lower potential minus sign will be written here. You understand? Now you are ready to move from A to B. So let us start moving. First if you stand on point A, then the potential of that point A is VA. You understand? You are starting from point A, then the potential of point A is VA. Now you come across this resistor. That means you are jumping from minus to plus, you are jumping from lower to higher potential. If you are jumping from lower to higher potential, you are gaining voltage. You are gaining voltage, that means this will become I into R. This is equal to plus 2. You understand? You will be gaining voltage, that will become plus 2. And by now you have reached this point. Now if you are jumping across this resistor, you are moving from higher to lower potential. You understand? You are jumping from higher to lower potential. You will be losing potential by how much? By I into R. That is, by the time you will be jumping across this, you will be losing potential of 3 volt. That is I into R 3. And by now you have reached this point V. Why minus sign? Because you have moved from plus to minus sign. That means you have lost potential. And by now you have reached the point B. So this is equal to VB. You understand? आप A से start कर रहे हो तो A का पोटेंशियल VA लिखा पहले, देन यू आर जंपिंग अक्रॉस दिस रेजिस्टर, तो आप माइनस से प्लस साइन पे आ रहे हो. दैट मीन्स आपका गेन होगा पोटेंशियल का बाय हाउ मच? बाय 1 into 2. दैट मीन्स गेन लिखा हमने, प्लस करके लिखा 2. अब आप यहां पे आ गए हो, देन यू हैव टू जंप अक्रॉस दिस. यहां पे जंप करेंगे तो ये आप हायर से लोअर पे जा रहे हैं, आपका पोटेंशियल लॉस होगा 1 into 3 से, दैट इज -3 लिखा हमने, एंड यू हैव रीच्ड पॉइंट बी. अब आप पॉइंट बी पे आ गए, इसलिए दैट इज इक्वल टू VB. दिस इज द वे द इंटायर इक्वेशन इज रिटन. सो नाउ you can write VA minus VB. This is equal to 1 volt. You understand? So this is the kind of difficulty level question on which Kirchhoff's law you will be applying. Now let us discuss a typical question in which resistors and capacitors, both of them are involved, which you call RC circuits.